Hello friends, here I explain you how to use for loop in the language software and what is meant by for loop. So here we see, here we go. Okay, what for loop? For why we are using the for loop? For loop is executed n number of time as a n we wire to the n count terminal. Okay, means execute a sub diagram set a number of times, and this value in this count terminal, as we take it as an input terminal, represented by the n iteration. In this for loop, the iteration count always start at 0. During the first iteration, the iteration terminal returns to 0. Okay, so it is a control flow statement. It shows how the one by one loop get executed in this for loop. So we will see in this flow chart how the flow it's carry. Okay, so here we take a count terminal as 100. I represent the iteration terminal that always start from 0 as I said previous. Then here we take a condition as I equals to n. If this condition is satisfied, then this loop is get terminated. If not, then it's incremented for 1. It's incremented for 1. For the last iteration, it's this I equals to n condition is satisfied, then the loop get terminated. Means this loop is looping is happen for the 100 count. Means 100 times this loop will be executed again and again. So this is a flow of this for loop. After that we will see the how to build a for loop in the LabVIEW software. So in this we have to open go to this for loop software. In this we have to open the we can open this blank VI by selecting the file and then new VI. So two panel is generated, that is front panel and the block diagram. In the block diagram, inside in the free space is there. So in this free space, right click over there and function palette is generated. And this inside the function palette, program is there, and this program under the programming structure palette is there. In this structure palette, under the structure palette, for loop is there. Select this for loop, drag into this block diagram. So how it's look like this while we are right click on this block diagram, it shows like that. This is function palette. Inside that block diagram, under the block diagram, structure is there and structure for loop is there. Then how to convert this from the while loop to for loop or for loop to while loop, vice versa. And by right clicking at the edge of this while loop, this window is appear, and here it say the replace with the for loop. So click on this replace with the for loop, it's replaced to the for loop, and vice versa. From the for loop to while loop, we are change this loop. This then at the left corner of this for loop, then n shows the count terminal. This count while right clicking by right clicking on this count terminal, this window is generated that create a constant, create a controller, and create an indicator. So count terminal is means for that count terminal is specify the number of times to execute a code inside a for loop. If you wire the 0 or the negative number this to this n count terminal, then this loop does not execute it for the 0 and the negative number. So now you will see in this LabVIEW software how it's work. Right click on the blank space, under the structure palette, for loop is there, drag into this block diagram. This is a output terminal. Here we in this side we see the in this front panel we see the output. This is a n terminal. right click and create a constant. Here we place any number, as I put 100 for the 100 count, and then right click again under the numeric, select a random number, and again right click, select the multiplier, connect the wire between random number and the multiplier, and then create a constant for 10 and connect one indicator at the output terminal. That indicator shows the output in the front panel. Okay, while running this program, it shows the flow of this. By this highlight execution, this shows how the program get flow of this program. 0.72 going to the multiplier and 10 multiply with and gives the output as 4, then 7. This loop is executed for the 100 count terminal. This is for stop the execution debugging. The next example we will see for the adding the sum of first 5 number, for the sum of the first 5 natural number using the shift register. So go to the select the add, then create a count for the 5 numbers. At the right click on the edge of this for loop, add the shift register is there, click on that. Shift register appear in the for loop. This is a left shift register, and this is right one. This right one we had to connect this output of this add function, and on the left one we have to add a input over there for the addition purpose. So I create here the constant of 0, then input of the shift register connected at the addition function, and then iteration, so connected to the addition terminal. So at the output, create one indicator that shows the addition of all 5 numbers in count of this. At the each and every count, the number is added one by one for the 5 times. Then again connect the auto index tunnel and create a indicator as an array. That array shows the loop iteration for the 5 number. So this shift register, this auto indexing, this is a loop tunneling that allow you to pass the data through the loop. The shift register access the data from the previous loop iteration and pass the data to the next loop iteration. For that purpose we are using the shift register. And this auto indexing, when you wire the array to the input tunnel of the for loop, then auto index terminal read and process one element in the array per loop iteration. This per loop iteration data show in this array. So now I run this program. This shows the flow of this diagram. This is highlighter that showing the for the 5 counts. After the completion of 5 counts, here the generate the output and add from the 0, because here I took the 0, from the 0 it start adding one by one, and the final output is 100, and this numeric palette shows the total addition of this 5 number. For after that, uh, if necessary, for the here is a one another input terminal is there, means a condition terminal, we can say as a condition terminal. So what is that? Let us select again a for loop. So this is a in loop count. This is not a conditional terminal. If it is necessary to add the conditional terminal to configure a for loop, store when boolean condition or when error occurs, for that purpose we have to add the conditional terminal. The conditional terminal allow you to specify the additional condition for the stopping the for loop. For loop normally stop after the executing the number of iteration you specify using the count terminal. However, you can use the conditional terminal to stop the for loop when other condition occur, such as error. So while right clicking on the edge of this for loop, the conditional terminal is there. Select this, right click on this conditional terminal, red glimpse in the count terminal is appear. Okay, for loop with the conditional terminal executed until the condition occur or until the all iteration are complete. The following for loop generates a random number of every second until 100 count has passed or the user click the stop button. This is the stop button. This is a loop condition. This is a default set as a if true. This is defaultly set as a if true. We can change it as if you want to change it as continuous if true, or so this is for the conditional. If we apply the condition for that, so add this. Select the random number, add here, then select one incremental that increment the loop. No need for this. Here I connect the create a constant for 5, and then here I connect one constant if false, if true. So I set is if true, then this terminal get for looping a stop. Then I connect one indicator. While running this program, start continuously running. First count then second count, then third count, fourth count, this condition is occur here. So while continuously running, after the count, if the condition is true, then for the true condition is appear as a 051425. This is a value for this. Thank you.